Okay, one more example involving ellipses. The orbit of the Earth is an ellipse with the Sun at one focus. That's a fact. The planet's maximum distance from the Sun is 94.56 million miles, and its minimum distance from the Sun is 91.45 million miles. What is the eccentricity? So let's see if we can visualize what's going on here. We've got the orbit of the Earth is an ellipse, and the Sun is at one focus. So as the Earth goes around the Sun, sometimes it's farther away and sometimes it's closer to the Sun. When it's at its farthest, that would be at the vertex that's furthest away from that particular focus. Its distance from the Sun is 94.56 million miles. When it's closest, that would be when it's at the other vertex, the one that's closest to that particular focus, its distance is 91.45 million miles. And the diagram here is not to scale. 94.56 and 91.45 are a lot closer to each other than they look in this picture. I've kind of exaggerated the difference just to make it a little easier to think about what's going on. Now, the length of the major axis, stretching from one vertex to the other, would be if we just added those two distances together, 91.45 plus 94.56. So that adds up to 186.01, which is 2a. So a would be half of that. 186.01 divided by 2 is 93.005. And you may have remembered learning that the distance from the Earth to the Sun is about 93 million miles. Now, C would be, well, if we have A, that's how far it is from the center of an ellipse to a vertex. C would be the difference from the center to the focus. And we have enough information to figure that out because we can take A from the center to the vertex minus the distance from the focus to the vertex, which was 91.45, and that would give us C. So C comes out to be 1.555. So the Sun at one focus of the orbit, one focus of that ellipse, is about 1.555 million miles away from the actual center of the Earth's orbit. Now the eccentricity E would be C over A. 1.555 divided by 93.005, and that comes out to be about 0.0167. That's a pretty small number for an eccentricity. It's not very much bigger than 0. And remember that the closer the eccentricity is to 0, the more nearly circular an ellipse is. So for something like the orbit of the Earth around the Sun, it's an ellipse, but it's pretty close to being a circle. It's very nearly circular, more so than it looks like in this picture. And that's true for most planetary orbits. Although with something like a comet, something like Halley's Comet, every so often it comes in close to the Sun, and then it goes way out into outer space, and its orbit around the Sun is also an ellipse, but the eccentricity of that ellipse is much greater than it is for something like the Earth. That ellipse is much less circular than the orbit of the Earth or one of the other planets.